All right, in this screencast, I hope to help you identify how to predict the products if you know what type of an equation and what the reactants are. All right, so how to predict the products. First of all, you have to figure out what type of equation you have, and once you know whether it's synthesis or decomposition, single replacement, double replacement, or even combustion, then you know what the product should look like. There are certain characteristics which are going to help you decide what is formed. And remember, whenever you're writing writing formulas in a compound, you still have to cross the charges and use if it's a diatomic molecule. All right, so let's start with double replacement. In double replacement, you have two compounds and you switch the partners and form two new compounds. Remember, you have to have likes replacing likes. That would mean metals replace the metals, nonmetals replace the nonmetals, and you always still have to write them with the positive part first and the negative part second. Lastly, you need to cross the charges. So if you look at this equation, you have A plus B and AB and CD making a new compound, and your A goes with the D and your C goes with the B. And if you think in terms of math with they use FOIL, first and last, inside and outside. The first and last works well, but the inside and outside, make it fit however you need to remember it. But remember, you have to have the positive part first and then the negative part, and you cross your charges. So here's an example, NaOH and CaSO4. So we know from our model that the Na is going to combine with the SO4 and our Ca is going to combine with the OH. But we also need to look up the charges on the Na, the OH, the Ca, and the SO4 and then cross the charges. So Na and SO4, Na is a +1, SO4 is a -2, so we would have to write it Na2SO4. And then in the OH is -1 and the Ca is +2. So when we crisscross it, we're going to get CaOH in parentheses 2. So that's how you do a double replacement or double displacement predicting the products. All right, here are some examples. Take a minute, work through these, and then you can press play again and see the answers. So like I said, take a minute, push pause, work through these and get your answers on your paper, and then start me back up and you can see the answers. Okay, so NaOH and HCl will form NaCl and HOH, which can be written as H2O, that's fine too. CaSO4 and KBr will form CaBr2 and K2SO4. Now, this equation is not balanced. We're just focusing on writing the products. You have Al2O3 and FeCN in parentheses 3, and when you crisscross them and switch them up, you get AlCN in parentheses 3 and Fe2O3. And then the last one is AlCl3 and BaSO3, and when you crisscross them, you get Al2SO3 in parentheses 3 and BaCl2. Remember, these are not balanced. All right, so looking at a single replacement reaction, this is where a single element cuts in on the compound or its like component in the compound. So again, we still have metals replacing metals and nonmetals replacing nonmetals. So you need to figure out the part that's by itself. Is it typically a metal? Well, is it a metal or a nonmetal, or is it typically a positive or negative charge? It will replace its like part within the compound. When you write your compound, you still have the positive part first and the negative part second. You still have to cross your charges. And if that single element is one of the diatomics, you have to write it with its subscripted too. So let's look at this example. We have NaCl plus F2. So the F is a nonmetal, so it's going to replace the nonmetal part of NaCl, which is Cl. So we will make a compound of NaF, and we have crisscrossed the charges because Na is +1 and F is -1. So no charges are written. And then we have Cl by itself, but Cl is one of the diatomic molecules, so it would be Cl2. All right, so there are some rules to help identify if this reaction will actually occur. This is the model and this is what happens, but we need to decide if this element is reactive enough to replace the element that is in the compound. And how we decide that is using an activity series. So if our element were nonmetals like we just did, this list is in order from low activity to high activity. And a compound always will replace to be active with another element if it can. So what I mean by that is if an element is more active, it would rather react and be in a compound instead of being by itself. So in our case of our Cl and our F, back here, our Cl is in the compound and F is by itself. So we want to see if the F is active enough to replace the chlorine. So in our equation, in our activity series, we have F is the most active and Cl is not quite as active. So as you can see, F is the most active and it will react any chance it gets to become in a compound. So if we go back and look here, this equation, this reaction does in fact occur because the F, the more active element, wants to be in the compound. So you can also have a metals activity series, and you can see that this order it's a lengthy one. It goes from gold, platinum, mercury, silver, copper, all the way up to calcium, barium, potassium, and lithium. The metals down here on the low end are the ones that we can wear in jewelry because they're not going to react with everything that they come in contact with. However, the elements up here on the end, the high end, are elements that will react just in the air, so they wouldn't make sense to be a jewelry metal because they would probably react on our skin. So you need to have either access to an activity series or have it memorized. Memorization is not required in this class. You should be able to look at the list and identify if a metal will replace into the compound and push off something that's less active. So here is some examples, and I have given you the activity series down here on the bottom in the correct order. This side on the right being the high end, the side on the left being the low end of activities for both metals and nonmetals. And there are 4 examples here, and it would make sense to go ahead and push pause, try these, see if they react. If they don't react, write no reaction, and then push play and come back and see the answers. All right, so Mg and CuO. So we're looking at Mg and Cu, and we're trying to see is the more reactive element in the compound. So we can find Cu down here, and we can find Mg here. And Mg is more active, so it is going to push the Cu out of the compound, and you're going to form Cu by itself and MgO. Okay, the next example, you have Au and Na. Au is the least reactive, Na is up here toward the very high active end. So Na wants to be reacted in a compound, so it is not going to get pushed out. So in this case, there is no reaction. Cl2 and KBr. We're looking at Cl2 here and Br there. Cl is more active, so it wants to be in the compound, so it will bump the Br off. So you'll have Br2 and KCl. And then I2 and F3, you can see I2 is very low reactivity and F is very high. So F wants to be in the compound as it is, and so no reaction will occur. I will say that the Cu and the MgO and then the Br and the KCl could be flip-flopped in the products. It doesn't matter which substance you write first. All right, another type of reaction to predict the products is for synthesis. And what this is, it says all reactants add up into one product. Synthesis and combination reactions, if you remember, they have just one product and they can have as many reactants as possible. And so you need to add them up so that they all still make sense. Charges need to be crossed. Sometimes there could be more than one possible answer, but usually there's not. So in our case, our example here, we have A plus B plus C, and it would make a compound ABC, showing that all the reactants have to be combined into a compound for the product. So our example here is Mg plus O2, and when you put them together, you get MgO. All right. The 4th reaction is a decomposition, and if you remember, decomposition is when one reactant breaks down into multiple parts. Usually you get single elements, sometimes it doesn't have to be, but do remember that if an element is one of the diatomics, it needs to have a subscript of a 2, and then you would balance the equation. So in our example here, we have DEF would break down into D plus E plus F, and so you have an example of AlCl3, and when you break it down, you have Al and you will have Cl2. Now the 3 does not automatically get moved over. The 3 is just part of the crossing the charges, but in this case Cl is a diatomic, so it gets a subscript of a 2. And then the last one is a combustion reaction. And remember, combustion defines what its products have to be. It has to have H2O and CO2. The reactants can only have carbon, hydrogen, and oxygen sometimes. It doesn't always have to have oxygen. In the first compound, it can, but then it also has to have O2. What I mean by that is you can see this first reactant is C3H6 with no O on it. Sometimes there's an O in this first substance, but you always have to have O2. And because this is combustion, you know that your products are CO2 and H2O. Okay, if you have any questions, go back and look through this. You will have an activity series anytime you're doing work in for the tests. If you go on to AP Chemistry, well, the activity series needs to be a little bit more understood, and we'll talk about that later on in that class.